Hello everyone! Chapter 10, Transformations. This is LT1. This is Miss Osier.
And Miss Lahar.
And here we go. I like to move it, move it.
I like to move it, move it.
I like to move it, move it.
I like to move it.
You're welcome. Okay, so we're moving things, people.
Yep.
We're translating them, reflecting them, basically those two. We're also dilating, but not yet.
Yep. So yesterday in one of those things, it did say that we really start with one equation and then we just do things to it to move it.
There's one absolute value graph ever, and then we just move it around. So this would be moving it up 2 and right 3.
Yep.
So here's a quick chart. I'm just gonna quickly just throw up there. Basically, K is a number, okay? And that's what you're moving by. So if it's on the outside of the function, it's gonna be up and down. If it's on the inside, it's gonna be left or right. And hopefully you realize by playing around that it's the opposite of what you think.
Yep.
Boom.
Oh boy.
You gotta know your functions. We'll call them parent functions, but again, in the activity it said there's only one line, there's only one parabola, there's only one all of these things. We call those the parent functions. You should know what these look like so that if you see a graph, you can write it's the square root, etc., etc.
So those are just a reminder of our friendly filled,
And then
parent function.
basically, like we say no calculator because you're supposed to know these without using the calculator.
Yep.
So you're supposed to be able to look at this +3 on the outside and say, oh, that's up 3. Look at the +3 on the inside and say, oh, that's left because it's the opposite on the inside. 3.
Yep. Ooh, I got the next one. It's an absolute value. We're going down 2.
Down 2.
And right 3.
Hey, look at us go. And it should be this easy. And you should feel comfortable at this point because like you were doing it.
All right.
Identify the parent function and write an equation for the function given. Well, number 3 definitely looks like a parabola, so that's an x squared.
There's the parent function.
Okay. And now we have to move it. So you need to know that a parabola, its vertex is usually at 0, 0.
Like the parent function's vertex
Right.
is 0, 0.
So write 1 up 2. So how would we write that?
Right 1, up 2. That's how we would write it physically.
So then remember, the inside is going to be your left or right, and it's going to be the opposite, so -1. And then it's right inside of the function. That's what we mean by that. And then the +2 goes on the outside of the function.
Okay. The next parent function, we're talking with an absolute value, baby.
Boom.
Looks like that. Now, again, this one starts at 0, 0. The vertex is usually, so I'm going left 1, down 2, which would mean I'd have +1 on the inside, -2 on the outside.
Look at us go. Okay, so now they're giving us the 2, and they're not asking for the parent function. They're just asking us to write g of x in terms of f of x. This is very similar to what you were doing on the activity. So you just say, okay, so that point went there, so that's right 3, down 1. And then instead of writing like the square root of x -3 with minus 1 on the outside, you're just writing it with f.
Right. In terms of f of x.
That's what it means with in terms of f of x. It just means some function, blah,
Right.
blah, 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 blah.
Yep.
And it could be any function, which is, I prefer this way because then I don't have to remember my parent graphs.
All right, so that one's going to be the trinomial. So if I put my critical point, or whatever point you want to pick, it moves right 3 up 2. So again, g of x equals f of x -3, and then +2 at the end.
Boom, look at us go. Okay, and then sometimes they'll give you a graph and they'll just say some function. So they're just drawing something. Like I could draw a smiley face and tell you to translate it if I wanted to. I couldn't say it was a function because it wouldn't pass the vertical line test, but that's in another chapter. Okay.
So this one is f of x. So I drew in some points, like our critical points that make your graph. Just make your life easy. You don't have to do all the points. Just do a few.
And what is this telling you to do? I always look at this first personally, but you do it whatever way you want to. So I see that I'm going down 4 and left 1.
Ooh, nicely done. So just move all those points. That's us moving those points.
Left 1, down 4. Left 1, down 4. Left 1, down 4, etc.
And then you connect your dots.
Look at that.
Look at that.
So pretty. Okay. Now, let's talk about reflecting. You should have realized that the graphs could flip. So they can flip over the x-axis, which is kind of like flipping up and down. That is when the negative is going to be on the outside of the function. And if it reflects over the y, left and right reflection, it's going to have a negative on the inside of the function.
Inside, outside. There's going to be a lot of rules in this chapter. So
And it all is based off of inside and outside. So realize when we say outside of the function, we mean this. When we say inside of the function, we mean this. Okay.
Ooh,
So
snap.
what's happening? Now realize everything else that we already talked about is still going to occur. So I see a negative inside of the radical, therefore it's a y-axis reflection. And that +1's still hanging out, so that's an up 1.
All right. On the second one, I see a negative on the outside, so I know if it's going to reflect over the x-axis, and then -2 means it's going to go right 2.
Look at us go. Okay, so now be careful with these because, you know, you could technically like GCF the negative out, but it's still in front of. If it were inside of the function, you would have parentheses.
Yep.
Okay, so this is definitely outside. Oh, look, see what I was just talking about.
you would have that.
Yep.
Not that.
Not that. That.
That.
This would be an inside.
Yep,
See how the parentheses are
inside,
there?
outside.
This is not inside.
Okay.
Okay. So it's reflecting over the x-axis. That's what we were just talking to you about all of that for. And then the -2 is outside because, again, it's not in parentheses. Therefore, it's down 2.
Yep.
Yay.
Woo! All right. One's easier than the other.
Yes.
All right.
So when it says reflect over both this and this, assume that they're talking about separately. If this were ever on a test and you were unsure, you could ask us. People usually are like, am I supposed to do it one on top of the other or do it separately?
Yep.
On the Regents exam, it would definitely be crystal clear what you should do, but we mean to do them separately.
Okay. So now we're going to do the x-axis because it's on the outside.
Boom.
Right? X-axis outside.
And you literally just put a negative outside of the entire function.
You can leave it like that or you can just distribute. It's, up to you.
And we just change signs. Yay.
Yeah.
Okay. Now, the y-axis is inside of the function. Remember, go back to function notation. This means negative x goes in everywhere you see an x. So I'm going to put a negative x in parentheses here. I'm going to put a negative x in parentheses here.
Ooh, a little bit different.
Okay.
Not everybody, but
now,
some people.
you could technically leave it like this, but we
Yeah.
want you to go further because we want you to.
Yep.
So negative x squared, any number in the whole wide world squared is going to be
Positive.
positive. And then negative 28 times negative x would be positive 28x plus 92.
And you have just reflected it over y and x.
Look at us go. Okay. Identify the parent function and write an equation for the function given. So let's just do another one real quick.
All right. Absolute value.
Boom. And it might be helpful to sketch that in. You don't have to, but that's in the red. I just sketched it in there real quick. Flip over the x-axis. That's definitely what occurred.
Yep. And then we moved it, what, left one, down one?
Because the vertex went left one, down one.
All right, so on the outside, because of the x out, we go left +1, and then you go down the -1 at the end, and there you go.
Yep. Look at us go. Okay, last one. Last one for real. Transform the given function as described and write the resulting function as an equation. So we're doing 3 things. Reflecting across the x-axis, translating left 2 units, translating up 1 unit. Always reflect first, it's easier.
Yep.
There's our reflection.
Okay.
Boom.
Then left 2, boom, to the x,
Boom.
function notation.
You do not have to show it in 3 separate steps. We were just showing it.
We were being dramatic.
Yep, pretty much. Have a wonderful day. We'll see you in class.